Okay guys, welcome to our science lesson for this week. It's been a bit of a change of plan. The weather has been too nice for me to do what I originally planned, which was having you go outside and jump in puddles basically. So I've changed it ever so slightly. So our learning objective for today is to explore the properties of water. We need to know that water is a liquid. And we're going to have a look at what it means by reversible and irreversible changes. And we're going to discuss how we may measure and investigate water changing. Okay, so it links into last week. So last week, what happened? The ice became what? So that's right, the ice became water. And it became water because it melts. Okay, so over time the ice melted if it got too warm. Now, some of you with the experiment that you did, some of it took ages to melt. Some of it probably melted quite quickly. I don't know. We had a bit of a strange reaction at school. One of the groups decided to wrap it in straw. There was still little bits of ice left in the morning. So it was either very cold in the classroom or the straw did a really good job at stopping things from melting. And the reason why, and I'm going to tell you this now actually, you may have already knew this, but the reason why the salt or the sugar melted it quicker was because what happens is the salt or the sugar changes the melting point of ice. So it makes it a much lower melting point. So normally ice would melt at 0 degrees. That's why freezers have to be minus numbers. But salt allows it to start melting at a lot colder temperature. So it melted it quicker. Now, the melting of ice is a reversible change. Okay, that means that you can change the water back into ice by putting it back in the freezer. It is reversible. We can go back to the ice from the water. If it was an irreversible change, it means that you wouldn't be able to get back what you started with. And we're going to look at some irreversible change experiments a bit later on in the term. But for now, I just want you to know that anything melting is a reversible change, which means we can freeze it to get it back to ice. So, what are we doing today? What happens when it rains? Well, you get puddles. Okay, so here are some pictures of some puddles. When it stops raining, what do you think happens to these puddles and why? So I want you to pause the video now and I want you to have a really good chat, really good talk with your grown-ups, with your mums, with your dads about what do you think happens when the rain stops. What happens to the puddles? Okay, so pause the video now. Okay, what we want to investigate today is what happens to those puddles. Now, hopefully you might have come up with the idea that they stay there forever and ever and ever and ever and ever. Okay, it could be that they disappear. And they start to get smaller over time as well. And we're going to talk about that now. We're going to think about why a little bit later on. So I have emailed all mummies and daddies a little experiment to have a go at, but I'm going to talk through the experiment now. So you're going to need it says here half a teaspoon measuring. I don't think we should do that. I think we should put some more in. So I think you're going to need a measuring jug. You're going to need a measuring jug and you're going to need, I would say, about 100 millilitres of water. Okay, and what you're going to do is you're going to get 3 saucepans, or three saucepans, or a frying pan, anything that can hold 100 mils of water. Now, if you've only got 1 saucepan in your house, then you will have to do this 3 separate times. Okay, that might prove a little bit tricky, but don't worry. And you're going to put that 100 mils of water in the saucepan. Okay, in each saucepan. So you're going to have 3 saucepans of water, or a frying pan, each with 100 mils of water in. Okay? Nice and simple to start with. Okay, those 3 pans. Let me draw a third pan on here, otherwise it's going to get confusing, and I'm going to rub out the 100 mils of water. As I said, this is a little bit harder, a little bit trickier, because there's been no rain. Would have been a bit funner if we'd been able to go outside and do this outside. So the first pan you're going to do nothing to. Okay, so really it could have just gone in a bowl, but that's fine. The second one you are going to heat on the hob. Okay, and then the third one you're going to blast with a hairdryer. Now, hairdryers get quite hot, so you might want a grown-up to do it. Okay? Now, what you need to do is you need to time it. I would say probably for about 5 minutes. No more than 5 minutes, because you don't really want to be holding a hot hairdryer for more than 5 minutes. So I would say put a timer on for 5 minutes, heat up the water on the hob, and blast the other saucepan with a hairdryer for 5 minutes. Okay? I'm going to move on to my next page, because this is what I want you to do in your book. So, in your science book, I want you to draw 6 boxes. And the top 3 boxes, you're going to have your saucepans with water in. And I would put a little measuring jug with a little bit of there, and you're going to put 100 ml. That shows that you've put 100 ml of water. You're going to colour this in much better than me. So you're going to do that one, and you're going to do it 3 times. So, because we want it to be a fair test, which means we need to have the same amount of water in each saucepan. Okay? You can put 100 ml underneath here as well, but I want you to draw the jug each time. Okay, so you should have, this is your starting point of your experiment. Okay, what you're then going to do is you're going to write 5 minutes by the next set of 3 boxes. Okay, and what you're going to do is you're going to pour the water. So this, or you need to, oh, sorry, my fault, you need to label these. So this was nothing. This was on the hob. And this was the hairdryer. If you want to do them a different way, that's fine. But those are the 3 labels at the top. So what you're then going to do is you're going to draw 3 jugs. And I want you to pour the water back from the saucepan into the jug each time and measure it. So you should have had 100 mils before and you did nothing to it. How much have you got now? and I want you to write it in this box. So if you think a little bit has gone and it's like 90 mils, that's what you would write. You're then going to do the same with the hob. So you've turned it off, you're going to pour the water back from the saucepan into the jug. How much is it going to be? Write it down on the line. And then the same with the hairdryer. How much water is left? Hopefully, there will be some changes. So I want you to go away and do that experiment now. And then I want you to talk to your grown-up about what you think is happening to the water. When you've done the experiment and you've talked to your grown-up, I want you to unpause the video and come back and listen to the last little bit. Okay, so off you go. Have some fun with water and heat and come back in a second. Pause the video now. Okay, so you've got your results. I'm not going to talk about what your results are going to be or what I think they should be, because you might have all got different results. I don't know. But why? Why is this happening? This is what happens to puddles when they're left. Okay? They start to get smaller for two reasons. One is because they get heated up. Water heats up and they do something called evaporation. So I'm going to write on this line, the water disappears because of evaporation. Now that's where the sun heats the water and the water is actually turning. So when ice turned into water when you melted it, when you heat up water, it turns into a gas and it disappears into the air. That's what happens. So the water disappears because of evaporation. That's one of the ways the puddles get smaller. The other way puddles get smaller is it's sucked into what it's in, what it's on. So if you were to pour water onto the grass, for example, lots of it, you might see it appear to begin with, but then it would soak into the ground. So water, not that it would happen in this, and actually we don't need to write it down because this is about puddles and not the experiment. But water actually soaks into the surface that it's lying on. So it might soak into the soil. It might soak into the pavement. There are some things that are waterproof, and if it's waterproof, it will not soak into it. That's the whole point of waterproof things. So things like umbrellas or waterproof coats, if you were to put your coat on the floor and pour water on it, that water would never go away. Okay, unless it was warm and hot and it would dry up. Okay, but it would never just soak into your coat. So that is what happens to puddles. Now, I wish you could have gone out and measured puddles and had to think about this, but because there's no puddles today, you're having to do this experiment instead. We haven't even been able to do it in school. But it's all about, I can't even spell disappears. Look at that. That's awful. It's all about evaporation. Water becoming a gas and going into the air. Okay? So I hope you've learned something today. I'm sorry it wasn't what I'd originally planned, and it might have been a little bit more work, especially in your books. But next week, I promise you, we're going to have some fun. We're going to also have some fun with heat as well, but we're going to have a look at another reversible change. Okay, so good luck with your experiment. I hope your experiment went fine, and I'll see you next week in school for science. Woohoo!